Let's take a look at this problem. We got f of x is equal to x plus 1 over x minus 2. And what's a sketch graph? We want to find intercepts. So for x-intercepts, you always plug 0 into the other variable. So plug 0 in for y. So we got 0 is equal to x plus 1 over x minus 2. Whenever you're finding intercepts and you got a single fraction equal to 0, you can just set the top part equal to 0. So we got 0 is equal to x plus 1. Take the 1 over, and we get x is equal to negative 1. We'll come back to that. Now for our y-intercept, again, you always plug 0 into the other variable. F of x is the same as y. So plug 0 in for x. So we got 0 plus 1 over 0 minus 2. So we get y is equal to negative 1/2. Now our vertical asymptote. First step is to factor the top back to the bottom. There's no factoring needs to be done. Second step is to cancel. Can't cancel anything. Step 3, set our denominator equal to 0 and solve it. So we got x minus 2 is equal to 0, or x is equal to 2. Horizontal asymptote. Degree of the top is 1, degree of the bottom is 1. So the degrees are the same. So we're going to create a fraction, taking the numbers off the front of the x to the largest power. So there's an invisible 1 here, invisible 1 here. So we'd have 1 over 1, or y is equal to 1. Okay, now let's look at our increasing, decreasing, min, and max. Well, we need our derivative. And if we're going to find derivative, then we're going to use quotient rule. Top part is p, bottom part is q. We need p prime. Derivative of x plus 1 is 1. And we also need q prime. The derivative of x minus 2 is 1. Now our formula for the quotient rule is p prime q minus p q prime over q squared. So our derivative, p prime was 1, times q, which is x minus 2, minus p, which is x plus 1, times q prime, which is 1, all over q squared, which is x minus 2 squared. So that gives us x minus 2, and remember, a negative out in front of your parentheses flips the sign of everything inside. So that's going to give us a negative x minus 1 over x minus 2 squared. Now x minus x drops away. Negative 2, negative 1 is negative 3 over x minus 2 squared. Well, we want to find our critical values. And when you got a fraction, you set your top equal to 0 and you set your bottom equal to 0. Now, there's no need to set negative 3 equal to 0 because there's no variable there. So we'll just set the bottom part equal to 0. So x minus 2 squared is equal to 0. Whenever you have parentheses to a power equal to 0, you can just set what's inside your parentheses equal to 0. So x minus 2 is equal to 0, or x is equal to 2. Well, we want to build a table of intervals based upon that critical value. Clear over here is negative infinity. Clear over here is positive infinity. We want to choose test cases. Not that it matters. But I'll put in 0, some value between negative infinity and 2. And over here is some value between 2 and positive infinity, like 3. Why did I say it didn't matter? Well, take a look at our derivative here. The bottom part's squared. Whenever you square something, it's always positive. And the top is always negative. Negative divided by positive is negative. So this will be decreasing, and this will be decreasing. So our graph is decreasing from negative infinity to 2. And it's decreasing from 2 to positive infinity. Well, now we're ready to sketch the graph. There is no mins and maxes, by the way, because the increasing and decreasing doesn't change. We said x-intercept is negative 1. Okay, so go to negative 1, and there's my x-intercept. My y-intercept is negative 1/2. Negative 1/2 would be somewhere there. Vertical asymptote is x equals 2. So I got a vertical asymptote right there. And we got a horizontal asymptote at y is equal to 1. There we go. Well, we said it's decreasing from negative infinity to 2. It can't be up here because that would be increasing, and even more than that, there would have to be a y-intercept up here. So I know it's not there. And it's skimming this line and skimming this line and passing through these points. So I know it's going to go like this, come down something like that, and up here it's going to go like this, skimming those. Now over here, we said it's decreasing from 2 to positive infinity. If I put it down here, it'd be increasing. And even more than that, it would cross the x-axis, so I'd have to have an x-intercept, which means it has to be up here. And it'll be skimming those lines right there. Probably not worth the effort to draw or get some extra points to try to get a better picture. We're just sketching it. So that would be your answer.